say you have y equals x squared plus sine x. Y equals x squared plus sine x. In this case, y is explicitly defined in terms of x. Like there's only x's here, right? You have a formula for y. There's no y's here. So you have a formula. So you could find the derivative. It would be pretty easy, right? It would be 2x plus, what's the derivative of sine x? Do you remember? Cosine x. Good. So I won't write it, but that would be the derivative. So it's easy to do, right? You can easily find the derivative. So here, y is explicitly defined. Explicitly defined in terms of x. I'll go ahead and write that. I won't be lazy. In terms of x. Sometimes you'll see that in math class. They'll say like, solve for y in terms of x. Well, we've done that. We've accomplished that. You only have x's here and you have a y here. So that's what they mean when they say in terms of x. Okay, so that's explicit differentiation. You can easily take the derivative. That's called explicit differentiation. So let me just do it. Why not? I said I wasn't going to, but let's be different. So it'd be 2x plus cosine x. Right, cosine x. Derivative of sine is cosine x. So that's easy. That's what we've been doing. And that's the majority of the test. So what if instead we had something like this? X squared y to the fourth plus sine y equals x. So in this case, it's probably impossible to solve for y because we have y to the fourth power and the y is inside the sine function. So it's probably like not possible. It's probably impossible. So here y is implicitly defined. So implicitly defined in terms of x. Defined in terms of x. So what we're going to do is we're going to find the derivative of y without actually finding y. So we're going to actually find the derivative without actually solving for y, because it's probably impossible to solve for y. So how are we going to do that? I'll show you. That's the whole point of the section. So the whole section is the same thing. It's just finding the derivative of y without actually having to find y. On an exam, it'll tell you to use this. It'll say, use implicit differentiation, so you'll know. So like you'll know when it's this. It makes it easier in that sense. So let's do some warm-up problems. I have some in my notes. Almost no notes, but I should try to follow them. And we'll build up to it so you see how it works. Hey, all right. Good stuff. So let's say we have y equals x. Let's start off really simple. And let's find the derivative of this thing. The derivative, super, super simple. So what's the derivative of x? Does anyone know? 1, yeah, 1. So the answer is 1. Let's overcomplicate it, because it's good for us. So let's take the derivative of both sides with respect to x. So if we have y equals x, we can take the derivative of the left-hand side and the derivative of the right-hand side. To do that, we use this notation here, d dx of y equals d dx of x. Right? You could do that. You could overcomplicate it by saying, hey, take the derivative of y. So d dx of y equals d dx of x, right? Just to overcomplicate it. You could also write d dx of y as dy dx. You could do that. It's the same thing. That's the same thing as y prime, so life is good. Then you can write this as dx dx. You could do that, right? If you really wanted to make it look weird. It's still correct. But we know that the derivative is 1. So dx dx is equal to 1. And it kind of agrees with cancellation, right? You see, like it's like the dx's cancel, right? So the point I wanted to make here is that dx dx is equal to 1. I'm going to put that in a box. So dx dx is 1. The derivative of x with respect to x is 1. We knew that, but just writing it in a different way. All right, let's do another example, just a little bit deeper. Say we had y equals x squared. Yeah?
For the first part that you did, when it goes from dy dx to dx dx to 1, like how does that?
How to get the 1?
Yeah.
Oh, because we know that y prime is equal to 1.
Okay.
And so these are the same, because these are the same. Good, good. Ask. No, it's good. It's important. Good. Good question. Yes?
So dx over dx, that's like y prime.
Well, dx means the derivative of x with respect to x. So it's 1.
Okay.
Because like if you took the derivative here, it'd be 1, right? So the derivative of x with respect to x is 1. So that's all. Good question.
dy dx is the derivative of y with respect to x.
Good. Very good. Huh? And y equals x. Yeah, so good. So good, really good question. So dy dx is the derivative of y with respect to x. We don't know what that is. I mean, y could be, if y is some stuff, typically we have to find dy dx. Dx dx is the derivative of x with respect to x, which is 1, right? Which is 1. Good, good, really good question. Okay, let's look at this one now and overcomplicate it. Like for true understanding, it's good to ask these questions. There's a way you can just memorize stuff, and I'll show you that too, but it's good to understand. So again, let's do it. So taking the derivative of the left, we get dy dx. That's the derivative of y with respect to x. I'm skipping this whole ddx thing. I'm just jumping to dy dx. Now it's overcomplicated. Well, first of all, let's make it simple. What's the derivative of x squared? 2x. Yeah. Now it's overcomplicated. Think of x as your inside function. So it's an inside function. So we're going to use the chain rule. We'll bring the 2 down. We'll leave the inside untouched. And then we have the first power here, right, using the derivative formula, because you subtract 1. Then you multiply by the derivative of the inside. Well, what's the derivative of x? 1. So it's just times 1, right? But I'm not going to write 1. I'm going to overcomplicate it. It's times the derivative of x with respect to x, right, which is 1, right? Just again, overcomplicating something that's really simple. Why? You'll see it's coming up next. So it has a purpose, I hope. So you put, yeah.
So is the derivative of x with respect to x always 1?
Yes, always 1. Right, good. If you have the derivative of y with respect to y, it's always 1 as well. And look, they cancel. You can think of it that way. It's intentional. It's on purpose. Oh, so what's dx dx? What's that going to be? 1. So we never do this, right? This is ridiculous, right? So there's no reason to do this other than what I'm about to show you. Okay, other than like the understanding of the next step. So now, let's go ahead and start with like a problem, like test level, right away. Let's just jump to it. I'm going to make one up because the ones in the homework are, okay, no, we can do number 1 in the homework. That's okay. That's easier. Let's do number 1 in the homework. So number 1. And we'll do as much homework as we can. These problems will take a little bit longer. Like it's a little more intense. This homework is considered much more challenging. So if 3x squared minus 4y squared equals 25. And the question is to find dy dx. And again, on your test, it would say that, okay? It will say use implicit differentiation, or it'll say find dy dx. That's how you know it's this. So find dy dx. Which is just finding the derivative of y with respect to x. The only thing is we're not going to find y, right? We're just going to find the derivative of y. So you'll see, it's a bit different. So you just start always by just taking the derivative. That's the first step. You just do it. So solution. So we're going to take the derivative of the left-hand side and the derivative of the right-hand side. So this derivative here is pretty easy, right, with respect to x. It'll just be 6x. So 6x. And if you really wanted to overcomplicate it, it'd be 6x dx dx, right? But what's dx dx? 1, so we don't care, okay? But you can think of it that way. Some people will write it. You'll see why. Now here, it's the same thing, right? We're trying to find the derivative. So we get minus 8y to the first power times the chain rule, the derivative of the inside. What is the derivative of the inside? What is that called? Anyone know? dy dx. That's the hard part, you see? So you're always using the chain rule. That's the key. It's just the chain rules. People have a really hard time with this. I've talked to people who have had Calc 1, Calc 2, Calc 3, and DE, and they get A's in all of them, and they don't understand this. It's okay, it's normal. It's supposed to be hard. Math is hard. But basically, you're just using the chain rule. Here it's 6x dx dx, but that's 1. Here it's 8y dy dx. What's dy dx? We don't know. We got to find it. What's the derivative of 25? 0. If you mess up there, it's like a -1 because I'll feel bad for you because that makes it harder. Like people will leave the 25 there. I'm like, no! Like, no, it's Everyone okay with the dy dx? Let me explain it again. So it's the chain rule. So here, overcomplicating it would be 6x dx dx. Right? The derivative of x with respect to x, which is 1. Here it'd be minus 8y times, and then chain rule, dy dx. The derivative of y with respect to x. Yes?
How come it can't be minus 8y dy over dy?
Because we're taking the derivative with respect to x. So there's a step I skipped. The step I skipped, I'll write it over here. I'll write big. So we have this. That's a good question. We could do it that way. We could make it harder, but watch. So the step I skipped was this. Good. So we're doing this. Good question. Maria. I thought that was it, but I didn't want to say it and be wrong. But like my name's not Maria. Okay. So you do that. So d dx of both sides. So that's why. Because the question wants dy dx. If it wanted dx dy, it would. Yeah. Let's say it wanted dx dy. This is going to seem really confusing, but let's do it. Why not? It's Calc 1, right? This is college. If you wanted dx dy, we haven't even finished that problem, but it's so fun. So if you wanted dx dy, it would be 6x dx dy minus 8y dy dy equals 0. I've never done this. It feels weird.
So it's like that first bit over there.
Yeah.
You just multiply it, type of.
Yeah. So that's what would happen there, right? But all the questions want dy dx. Don't worry, I'm not going to ask you for dx dy. That would be really evil. Like, part A, find dy dx. Part B, find dx dy. Part C, find the second derivative. No, okay.
The reason you put dy dx is because you're not just solving the derivative, you're solving the derivative with respect to x.
With respect to x. Yeah, so here it's d dx of everything. Right. So here's the step I skipped. I'll write it again because I feel bad. So here's the step I skipped. So this is the first step, d dx of 25. And the second step is what's on the board already. So it'd be 6x dx dx, which is 1, minus 8y dy dx, which is not 1. Right? Dy dx is not 1. We don't know what it is. And this is equal to 0.
Well, where do you get that y from?
This y?
No,
This-
the y with the d.
This one?
Yeah.
Oh, that's the derivative of y with respect to x. So when you take this derivative...
Derivative of the inside.
The inside, yes! Oh, you get it! Yes, that's it. That's what it is. It's the inside. Everyone see it? It's hard, right? It's a hard concept. That's it. And then the problems get really messy. This is like number 1. Right? So you can skip steps. No, I won't because more caffeine. So solve for dy dx. So minus 6x minus 6x. Usually you have 2 of these on your test from this section. 2. Just 2. A medium one and a hard one, or medium hard. Yeah, this one's a little bit too easy for the test. Usually you have like a product rule or something interesting. Now just divide by negative 8y. So this would be negative 8y, negative 8y. So we get dy dx. I love this stuff. This is what math is all about. 3x over 4y. Is that right? 4y? X 4y. And that's it. That's it. I used to teach concepts of calculus. It's like this, but easier. And this was the section that would like destroy people. Like it would just absolute chaos. They had a really hard time with this. It's considered very difficult. So, because conceptually it's hard. Also, the algebra gets a little bit messy too. So it makes it hard. You all have had pre-calc and trig, so it's a little bit better. Like you've had more math, right? The more math you take, the better you get. Let's do number 2. Let's do it. Number 2 is a good test question. Let's do it. Number 2. Usually you have one like number 2. It's a good, solid problem. So we have 4x squared y plus 8y squared x, 8y squared x, and that's equal to negative 3. Negative 3. Equal to negative 3. It's really good attendance in this class. Like, it's really amazing. It's really like a lot of people here. Like no one skips. Like there's people missing today, but like even then, like it's really full. So here we have a product. So we have to use the product rule, right? So you can think of this as the first, and this is the second. This is the first, and this is the second. So we have to use the product rule twice on this problem. I'm going to write the product rule on the board because maybe you don't remember. Maybe you haven't even started the homework. It's okay. No shame. The product rule says if you have f times g, it's the derivative of the first times the second plus the first times second. Yeah. Has anyone not started the homework? Anyone not started? No? Okay. You don't have to raise your hand. You haven't started it? It's okay. Just try to start. Yeah, it's a lot. 2, 2, 2, 4 is a lot. And adding this to it is a lot as well. Okay, so let's do it. So this is the first. So it'll be 8x. That's the derivative of the first. So 8x, that's the derivative of the first, times the second, which is just y, right? Derivative of the first times the second plus the first times, what's the derivative of the second?
1.
Nope.
dx.
Almost.
dy
dx. Let me pause here and go over that again. Right, because remember, it's what Maria asked. We're taking the derivative with respect to x. Right? It's not going to mess up. It's not going to mess with you and like flip them on the test. Don't worry. No.
If we're doing dx over dy, the x would be
The unknown, right? Yes, if you're doing dx dy, it would be 8x dx dy, derivative of the first times the second plus the first times the derivative of the second, which is dy dy, which is just 1. Right? That's if you were doing the other way.
okay.
But we're not going to be doing that. In the next section, we'll have more variables, but the derivatives are really easy. Like, it's really simple. It's the word problems that make it hard in the next section. Yeah. Okay, so that's that one. Then this plus sign is this one. Good stuff. Whew. Got to do it again, right? The derivative of the first. So it'll be 16y dy dx. Yes, yes it is. Very good. Dy dx. That's how pros do it, right? So it's 16y times the derivative of the inside, which is dy dx. Very good. That's the derivative of the first times the second plus the first times the derivative of the second. But what's the derivative of x with respect to x? 1. So I'm going to put the 1 there just for emphasis. What's the last thing on the right-hand side? 0. That's it. Let me pause here. I'll let you catch up, and we'll go over it again. I know it's tough. I know this is tough. There's this thing in the homework. It showed up one day accidentally. I usually don't look. And it's like danger. And like this was like the danger section. Like this section was considered, it was red. It had like a warning symbol. Like students have a difficult time with this section. I'm like, really? Like, but it makes sense. It's in this class, most people do pretty good though on the test. Like yeah, I think most people will get these right. So the derivative of the first times the second plus the first times the derivative of the second, which is just dy dx. And then plus derivative of the first 16y, chain rule, dy dx. Derivative of the first times the second plus the first times the derivative of the second. And the derivative of -3 is 0. 0. Tense, right? I know. It's a lot. Oh, just doing it so fast? You get you'll get good at it too. By the time you're done with this class, you'll be like, yeah, like a robot or a monster. Or maybe not, nothing negative. Okay, we have to find dy dx. I'm going to do it in 2 moves, okay? So basically, we're going to keep these on the left-hand side, and we're going to factor out a dy dx, okay? Then this and this, these are going to go to the right-hand side. We're going to subtract these over, okay? So I'm going to go ahead and write this down. So dy dx. And I'm going to go ahead and factor the dy dx out from these, okay? So parentheses 4x squared. You might say, what about this? We're going to write this down later. This is going to go to the right-hand side, right? So 4x squared plus 16y. So plus 16y, parentheses. So just pulling out.
Would it be yx because of the x multiplied to it?
I don't see it. Did I miss it?
Right next to the addition symbol. No, on the 16y.
16y dy dx.
And And the x next to it.
What x?
Next.
Oh, no! Yes. Yes, you're right. Thank you, Aaron. Yes, I didn't see it. Everyone see what he's talking about? My eye could not see that because my eye, yep, excuses. Thank you. Thank you. So that's points, right? Are we still doing points in this class? Mm-hmm. Did you all get any points last time? Or really? We're doing double points? Oh, we talked about that? All right, it's getting hot in here. All right, I don't know. I don't have the paper. I guess I'll start over. Well, no, I won't start over. I'll find the paper. I'll sort through it. I don't have a pen. Anyone can I have a pen, Ethan?
There you go. Nice
Thanks.
bright
Pink. Oh, this is an awesome pen. Oh, this is great. Oh, exam 2, Aaron has 2. And then I'll find the other paper, Aaron. And this is, wow, I want a pink marker. Like, oh my God, that's like awesome. That is great. Okay, thank you. So be careful, right? Watch out for stuff like that. Whew. Subtract this over. Thank you, Aaron. Negative 8xy, and then minus 8y squared. Right. So these go to the right-hand side. Good stuff. Yeah, common mistake, right? I mean, that happens a lot on tests. If you do that on a test, it's like a -1 usually. I usually look here. If this is right and you mess up after this, I'm usually pretty lenient. Like if you leave the number here, I'll give you a break usually. But like if these product rules are wrong, that's really hard to give a lot of credit. Because then that means you don't know calculus, right? It's like, oh. The hard part is like where to put the dy dx. You know, that's, yeah. Any questions? Any questions? Everyone see how we got this over here? We subtracted them over. Now we just divide by this stuff, right? By all of this. Let's divide by this. Divide by this. Oh, this problem is ridiculous. We can keep doing math here. So dy dx is equal to all of that. It's on the right-hand side. I feel like, so we can't cancel the x's and y's. Like that has a y, that has a y, that has a y, that doesn't have a y. So in order to cancel stuff, you have to factor stuff out. That one's missing an x. So I think what we can factor out from both is a 4, right? From the top and the bottom. So I'm going to do this. 4 negative 2xy minus, I'm not done writing, negative 2xy minus 2y squared. Everyone see that? And then here we have 4x squared plus 4xy. And then now you can cancel, right? So it does require some messy algebra. How did I know to do that? Because I was trying to figure out, when I saw the 8s and the 4s and the 16s, I thought, oh, 4 is a common factor. So if you wanted to show all of the work, in theory, you have to pull out a 4 in the numerator and in the denominator and then cancel. A really cheap way to do it is just divide everything by 4. Okay, you could do that, right? That's a shortcut way of doing it. That's what I wanted to do, but it's a classroom. I didn't want to like skip too many steps. So we have this. Then on the bottom we have this. This is number 2. So it's like we're barely getting started. So you see already it's tough. Yeah.
We didn't do that on the test, we take off points.
-1. Very common thing to happen. Yeah, it's just 1 point. Only, and it's not because I want to take it off. It's just because like I feel bad doing it, but I kind of have to because it's not simplified. It's not considered simplified. Yeah.
So it does have to be simplified.
Mm-hmm. Yeah. Yeah. I didn't think that would happen in this one. Yeah. I don't like doing that. I'll be honest. It's not something I'm a fan of. Yeah. But so yeah, please do that on the test. Wow. What a problem. So it cost me 2 points. Any questions on this one? Anyone like this stuff? A little bit? No? Does it seem hard so far? Like, seem tough? No? Okay, all right, let's see if we can find a harder one. Let's see. Number 3 is very similar. Do you all want to try number 3 maybe? Really quick? See if you can take a try. I'll write it on the board. You try it. See if you can do it, then I'll work it out. Number 3, then we'll do...
Problems like from like 2.2, 2.3. When we're doing like, when we have to bring up like the 1/2 and stuff because it's a square root, do we simplify? Do we have to bring it back down?
No.
Okay.
No, you don't. Good question, Aaron. No, you don't. Can you, oh, you closed it. Okay. It's x to the 4th. What? Oh, you got it?
Yeah. X to the 4th, y to the 5th,
Uh-huh.
minus y equals x.
equals x. All right, try to do it. See if you can do it. Take 5 minutes. Just see. Try to do at least try to do one. That way, it's not just me doing problems. Then after this, we'll do some harder ones, and I'll work it out. So it'll be good practice. Wow, so much homework. So you start with the product rule, right? Derivative of the first times the second plus the first. What's your name? Is it?
Your name?
No, I know we talked about this. Is it? It's John?
Yeah.
What's your last name?
Colin.
Okay. What is it?
T-O-N-G.
Okay. I know why I got confused. The guy in my other class, his name is also John, and his last name also starts with a T. so did you get it, Aaron? Yeah, the first step is right. It looks good. I think so. I think, yeah. Hey, hello. Got a haircut. It looks good, yeah. Looks sharp. So quiet. Can you do that? You can do it? No. Oh. Yeah. Yeah, it took me a lot of practice. Yes. Yeah. I know a guy who can make bird sounds. Like, it's really fun. Like he does it in class. Like, oh, everyone's like, what is that bird? Like, it's just him. It's like chirping sounds. Can I do it? Can I do it? Yes, all right, good. So solution. So you start by using the product rule, right? So you look at the derivative of the first times the second, etc. So the derivative of the first will be 4x cubed. That part's easy. So times the second, so y to the fifth. It's good that you tried one, plus the first times the derivative of this. So what would this be? 5 times dy dx. Yeah, very good. Times dy dx, right? That's the chain rule. That's the trickiest part, right? So that gives you the dy dx. Then minus, what would this become when you take the derivative? dy dx, yeah, dy dx. And then you just end up with 1, yeah, with 1 on the right-hand side. Who got this far? Just curious, who got this far? Okay, that's pretty good. It's really, really good. Good, it means you got it, it means you understand, right? Let me go over it again. So it's the derivative of the first times the second plus the first times this derivative here, which is 5y to the fourth, times the derivative of the inside, which is dy dx. And then this derivative is dy dx, and this derivative is 1. Yes?
How many points would you take off if we got the second dy dx but not the first?
I don't know. A couple. Yeah. So you just forgot everything but this one?
Yeah.
Yeah. You won't do it. You'll get it right. Good stuff. So now I guess we have to subtract this over and then factor out the dy dx here. So dy dx. So we'll have 5x to the fourth, y to the fourth. So 5x to the fourth, y to the fourth. And then factoring out dy dx from here is going to leave us with a 1. I'm not going to mess up. See, looking at me. No. So nervous. Equals 1, and then this is going to come over to the right-hand side. So 1 minus 4x cubed y to the 5th. Did I do that right? I think so. Yeah. Subtracted this over here. Pulled out dy dx from this and from this, right, from both of these. So it's fun to do that. And then this came over here, right? This came over here. All right. To finish, we just divide by this stuff, right? So I'm going to go ahead and write the answer up here. So we have dy dx equals, and then we're just left with that. So 1 minus 4x cubed y to the 5th over 5x to the 4th y to the 4th minus 1. And that would be the final answer. Anyone actually get the final answer? Anyone? Okay, it's pretty good. Good. So you see it's a little bit harder than what we've been doing, just like product quotient rule. Takes a little bit more work. Any questions on this one or anything else? Let's give you a minute to catch up. So, okay. Let's do something else. Let's do some more stuff. There's other questions in the homework besides finding the derivative. There's some where you have to find like the equation of the tangent line. Usually every semester I do one of the harder ones. But let me do the one that was on the test last semester that a bunch of people got wrong. So it's number 20 in the homework. So let's do that one, number 20 in the homework. We'll just skip around and do some different stuff. At some point we have to go to the next section. There is another section today, 2.6. So 20, they give us an equation, x squared over 4 plus y squared over, is it over 8? And what's it equal to, Josh?
Equal to
6? Oh, okay, weird. Okay, equal to 6.
And the point that they give is 4,
4, 4, thank you. Point is 4, 4. And they want the equation of the tangent line. This is the graph of an ellipse. So I want the equation of the tangent line to the graph of the ellipse. So equation of tangent line. So there's some in the homework that might appear to be harder, but I usually do those. And then last semester I put this on the test, and a bunch of people got it wrong. And the reason is this is a little bit different than the other ones. So before we do anything, it's good to rewrite this. So you want to think about it like this: 1/4 x squared plus 1/8 y squared equals 6. At least mentally, right? That threw a bunch of people off on the test last semester. I was like, oh, I'll give him an easy one, and I gave him this one. And then they didn't do this, and a bunch of them got it wrong. I'm like, no, that was like the easy one. Because they got confused with the 4, right? You can write it that way, right? So, okay, so now we'll take the derivative. So taking the derivative here, we'll just get 2/4. So it'll become 1/2, right? Because it's 2/4. So 1/2 x, right? Because it's really 2/4 plus, and then 2/8 will become 1/4. Go again, 1/4 y dy dx. Very good, dy dx. dy dx. And that's equal to 0. So last semester, a lot of people got this one wrong. I felt really bad because it wasn't my intention, right? So my intention was to give them an easy one because they had some harder questions on the test already. Try to like balance it out. I'm like, oh, I'll give them an easy one, like to give them a break on this, but that caused problems.
So you take the derivative of the y and then add the dy dx.
Yeah, it's
because it's in the respective x.
Right, because it's the chain rule. It's the derivative of the inside. So like when you do it, yeah, when you do it here, watch this. It's 2/4 x times the derivative of x with respect to x, which is just 1. Good. 2/8 y times the derivative of y with respect to x, which we don't know what it is. Equal. You see it?
Yeah, I see it.
Because dx.
I see it.
You sure? Yeah. It's weird, right? Yes. You could just memorize it too. Whenever you take a derivative and there's a y, you just put a dy dx. Right? Okay. Yeah, you just do that. You'll get it right every time. Okay. We have to find the slope of the tangent line. So we have to find dy dx. However, we have to find it at 4, 4. So at this point, we can actually plug in the numbers because all we need is the actual slope. Right? The slope of the tangent line is dy dx. So what you can do is just write that down. So like at 4, 4, just writing this down so like we're letting like whoever reading our work know what we're doing. So when x is 4 and y is 4, so you can just plug in the numbers for x and y. So you would get 1/2 4 plus 1/4 times 4 dy dx equals 0. So just plug in the numbers. You can always do that in these problems. So whenever you take the derivative, plug in the numbers, then find dy dx. So this will be 2 plus, oh wow, dy dx. How clean, really, really nice. Right, because 4 over 2 is 2, 4 over 4 is 1. So it worked out really nice. So that would mean that, I guess dy dx in this case would just be -2, right, -2. And this is at 4, 4, right? So we specified that so it's okay. I mean, you could add extra notation here, like you could draw a line, you could do this if you wanted to. However, it's not necessary to do this because you've already written it over there. But this would be the correct notation. I would let it go on a test though if you wrote it here. So you do have to indicate somewhere that you're plugging in the numbers, right? It's really important. So this is our slope, so this is going to be our m. This is going to be our m. Slope of the tangent line. Good stuff. So now we use that formula. I think it's been a while. I don't even remember the last time we did this. The one with the two things. What's it called? Do you remember the formula? The point slope. Yeah, good. Point slope. Point slope formula. And it's called that because it has a point and a slope, right? A point and a slope. That's how I memorize it, because that's how I know what it's called, right? The point slope. Then you plug everything in. So this would be our x1, and this is our y1. So you plug those in. So we get y minus 4 equals -2. Thanks, -2 x minus 4. Usually you have one like this on your test. You have a tangent line one. When I make the test, again, as always, I'll post a list of topics. We'll also have a review day, at least a half a review day for this test, at least half. And then after this test, we'll have full review days for each test, like a full 2-hour, 20-minute review. Yeah, it's awesome. It's good. So -2x plus 8. Right, distributing the -2. I guess add the 4, right? So plus 4 plus 4. So we would get -2x plus 12, right? Plus 12. Is that right? Let's think about something else. Zone out. I can't zone out. You can. If I zone out, it's like, oh. Why is he going out the door? Like, no. I heard there was this teacher once. I don't know who she is, or and she teaches here. And like in the middle of a problem, she would just like leave. So like, I always thought that would be really funny to see. Like, your class just walk out, like middle of a problem. M equals -2, just walks out. Like, it's like what? Any questions? Any questions on this one? All right, let's do something else. Let's do a harder derivative maybe. How about Any in the homework that looks scary that you want to? Yeah.
So this isn't really about the problem itself, but for the notation, for the point,
Yeah.
you have to have that line there as well.
This? Yeah, so this would be the correct notation. However, in this problem, if you didn't do it, I wouldn't take any points off because you wrote it here. Yeah, but you're supposed to. In the next section, it'll be a big deal, and we will use it. Good. Yes?
Usually 19.
Well, it sounds scary. Okay, because it's like the one before 20. Let's do it. Oh, yeah. Yes, that's the one I usually do in class. Let's do it. Yes. That's the hard one, I think. Yeah.
Could we use the question rule for this?
You could. But then you're going to get 0 when you take the derivative of the bottom piece, so it's more work. But you could do it. Yeah, let's do 19. 19's good. Yeah, it's a good one. So 19 is good. Can you read it to me?
Yeah. 3 parentheses x squared plus y squared.
Uh-huh.
And that's all squared.
Uh-huh.
Equals 100.
Okay.
And then parentheses x squared minus y squared. And then the point is 4, -2.
4, -2. Beautiful. Thank you. What's your name?
Sarah.
Sarah. Thank you, Sarah. Yeah, so the question is to find the tangent line. This is the one I usually do in class. In my opinion, this is the hardest one in the homework. But the other one was different, so this one is different. Same question, tangent line. Find the equation of the tangent line. So a good first step, is to just take the derivative, right? So you take the derivative, then you plug in the numbers. So solution. We have to use the chain rule. So it'd be 2 times 3, so we get 6. So 6, parentheses. Then x squared plus y squared. So x squared plus y squared. That's the inside piece. To the first power. Times the derivative, 2x plus 2y dy dx. Very good. That's the chain rule. Let me pause here. So you put the 2 in the front, you get 2 times 3 is 6. Leave the inside untouched. Derivative of the inside would be 2x plus 2y, and then the dy dx is the chain rule again, right? Pretty nasty. This is a number, and it's in front of some stuff with x and y, so it hangs out. So you can let it hang out, parentheses. Then it'll be 2x minus 2y dy dx. Very good. Excellent work. Good. Let me pause here. This is one of the key steps, right? So it's probably the hardest step, right, is finding the derivative. And again, I think it's the hardest tangent line problem in the homework. In the playlist, there's a bunch of these videos with these too. I did like all of them, or most of them, if you need more practice. Any questions? Any questions on this one so far? Everyone okay? Anyone? Yeah.
So you did 6x squared plus y squared times 2x. Why didn't you do the plus if it's because it's a chain?
So yeah, it's a chain rule. So you leave the inside untouched. 2 times 3 is 6. You subtract 1. And then times the derivative of the inside. The derivative of this is 2x.
There's a product which is you, or you add.
Yeah, the product is different.
Okay.
Yeah, this is just the chain. This is the derivative of the inside piece.
Okay.
Product is when like you have times. Like, yeah, it's different. Good. What do we do next? What do we do next in this problem? What do we do? Well, even better than that, even easier. What could we? What did we do in the last problem after we took the derivative?
You took the dy dx out. No.
What can we do right away? Instead of having to find dy dx,
Oh, you plugged in the.
plug the numbers in. Yeah, so plug the numbers in. So plug, let me write that down. Numbers in. This makes it easier. You could try solving for dy dx, but it's more work, right? It's harder. So on these tangent line ones, after you take the derivative, just plug the numbers in. It's usually better. So again, I'm going to write that down. So at 4, -2. So this is our x and this is our y. So I'm going to put, so x equals 4. I'm going to actually write it down so I don't mess up. So I'm actually writing it down just to really be specific. So it's going to be 6 parentheses. I'm going to skip some steps. So 4 squared is 16. So I'm going to skip that step. That feels really uncomfortable. It's too late. 4 squared is 16. 4 squared is 16. And then plus -2 squared will be 4. So 4. How many steps you skip is up to you. I just feel comfortable skipping one, right? So 16 plus 4. 2 times 4 is going to be 8, right? 2 times 4 is 8. And then this will be minus 4 because it's 2 times 2. So minus 4, and then dy dx. And then we have this other parentheses here. It's tempting to skip more. You can skip more if you want, but so 4 squared is 16, negative 2 squared is 4, 2 times 4 is 8, minus 2 times 2, which is minus 4, equals 100, so 100. Then 2x, so it's going to be 8 again, so 8. Really nasty problem. Oh, I almost messed up. What's this going to become? A positive 4. Everyone see why? Because it's negative and negative. So plus 4 dy dx. Wow, this problem is ridiculous. Feels harder than the last one, right? Yeah, it's way harder. It's good stuff. Any questions? Any questions so far? We got time today, I think. Yeah. Okay. Let's skip some more steps. This is 20, right? So 6 times 20 is 120, right? So 120. Let's do that. That might be a good. Right. So 6 times 20 is 120 because that's 20. And I'll go ahead and distribute the 100 here because we have to solve for dy dx. So we have to eventually distribute. So this will be 800 plus 400. Wow, 400. I think this is going to be, I think the answer is 11 over 23, but I might be wrong. I think the slope is 11 over 20. We'll see if I'm right. I don't know. If I am right, that's kind of sad that I have it memorized, but we'll see. So we'll see if it's right. All right, distribute the 120. 8 times 120 is 960, I believe. Right, because 8 times 100 is 800. 8 times 20 is 160. 160 plus 800 is 960. So you get 960 minus 480 dy dx equals 800 plus 400 dy dx. I don't like problems where there's lots of numbers like this. It's really easy to mess up when you have so many numbers. Like you make a little computational error. Yes, Ethan?
So with the 8 minus 4 dy dx and the 8 plus 4 dy dx, can you not do anything like that to cancel out?
Oh, yeah, I don't know. It's really, oh, yeah. I don't know. Is there like some voodoo magic we can do? I don't know.
Well, are we trying to solve for dy dx?
We are.
So you can't even get the negative 4 plus 4 because it cancels out the dy.
Right, because they're different.
So
Right? I guess not, but like maybe, I mean, it's kind of cool that that happened. I didn't notice that. Yeah, I don't know. There's probably a trick, but I don't know. Yeah, I don't know. Yep. Subtract the 960. So we get negative 480. I'm going to baby steps. I'm going to show some extra work here. So it'll be negative 160 plus 400 dy dx, showing lots of extra steps. All I did was subtract the 960 in this step. I could have done 2 steps at once, but I don't know. It's getting kind of nasty. I guess now we can subtract this over here. So that'll become negative 880, right? So negative 880 dy dx equals negative 160. Subtracting 400 dy dx, subtracting 400 dy dx, it's negative 880 dy dx. Finally, we divide by 880. So we get dy dx equals 160 over 880. That's 16 over 88, right? 16. Oh, I was close. I was close. What I say? So this is going to be what, 2 to what I say, 23 elevenths. I was close, but not enough. So 2 elevenths, 2 elevenths. So the slope is a fraction. It's 2 over 11. 2 over 11. That's the slope. What a problem, right? Problems are like epic now. They're like long and involved. Like it's a little bit more intense. Any questions on this problem? On this one? This one's a little bit more. It's kind of nice. Your test is far away too. You have a couple weeks, so like it's not like tomorrow or something. All right, let's use the formula. So y minus y1 equals m parentheses x minus x1. So I guess I should label stuff so I don't mess up. So this is our x1 and our y1, right? This is x1, this is y1. So x1, y1. So it'll be y minus negative 2. So it'll be y plus 2 equals 2/11 x minus 4. X minus 4. And you could multiply by 11 to make it easier to add the fractions, but let's just do it. So y plus 2, distributing would get 2/11 x minus 8/11, right? Because you do 4 times 2, 8/11. And then when you add the 2, you can think of 2 as a number over 11. 22/11, yeah. So we're adding 22/11 to this. Subtracting, thanks, good save. So we're subtracting, thank you. Oh, thank you, I appreciate it. Yeah, subtracting. So 22, so negative 8/11 minus 22/11 is negative 30/11. Thanks. Good, thank you. Good. Thanks, good. Wow, that was a lot of work. That was a lot of work. I'm glad we did it though, yeah.
You didn't put the notation you mentioned?
Oh, but we wrote it here, so it's okay. It's kind of like forgiven. Yeah. So as long as you write it somewhere, I'll let it go. Yeah, good. But good. That's good. And the next section, it's really important. So good. Neoma, right? Is it neoma? No? Oh, it is. Oh. Any questions on this one? All right. Maybe let's do one more. How about a hard derivative? One with the trig function. I don't know. Like 8 looks pretty annoying. So does 7. 6 is kind of annoying. So does 5. Anyone have a preference? One with the trig function? Let's do 8. 8 looks kind of nasty. It's got the secant function in it. No one likes that. So 8. Number 8. So number 8, can someone read it to me? Is it x? 1 over y. Okay, let's try this one. Actually, this is not so bad. So let's try this one, then we'll go to the next section maybe. So we have to find the derivative dy dx, right? So it might be a good idea to first rewrite this 1 over y, because we're going to have to use the chain rule. And the derivative of 1 over y, whenever there's a number up top, you want to bring the y up. Y to the negative 1. Yeah, so a good first step would be to write it like this, secant of y to the negative 1. I think this was on the test last semester. I think this exact problem. I think it might have been. Or maybe I put a cosecant here or something. It's like, oh, let me change it up a little bit. Like, all right, now we're ready to go, ready to take the derivative. So the derivative of x is 1, right, with respect to x. It's 1. Oh, it's been a while. What's
Secant tangent.
secant tangent? Very good, yes. So the derivative of secant is secant tangent. So here it's secant of y to the negative 1, tangent of y to the negative 1, times the derivative of the inside, right? It's chain rule. So now we're taking the derivative of y to the negative 1. So you put the negative 1 in the front, times, so it'll be negative y to the negative 2. What's missing?
dy dx.
dy dx, very good. dy dx. dy dx. Yeah, it's pretty tough. So let me go over it again. So the derivative of x is 1. The derivative of secant is secant tangent. And then you have to use the chain rule. So you have to multiply by the derivative of the inside function. So your inside function is y to the negative 1. So its derivative is negative y to the negative 2 times the derivative of the inside. Any questions on that one so far? Almost done. Almost done. All right, I'm trying to figure out what the best way to do this is. Obviously, the dy dx is here, so I'm thinking everything needs to go to the other side, right? So I think we can just do that. Yeah, We could divide by everything. Okay, let's write it like that. So dy dx. Let's divide by everything. So it'll be, even by the negatives, it'll be negative 1 over, and then we're dividing by the y to the negative 2. We'll clean it up in a minute. Secant y to the negative 1, tangent y to the negative 1. So I didn't do any simplification, which, yeah.
Where did the 1 from the left side go?
This one, it's still here. If I did it right, we just divided everything by this. So all of this came down here. So you see it?
But where did the negative go on the top?
This negative,
No, on the negative 1 on the top, on the answer.
this, it's here. Oh, where did it come from? It came from here,
Okay.
and I moved it up.
Okay.
Good question.
You just do y squared, so you can't y,
Yeah.
because it's already on the bottom.
Yeah, let's clean it up. Yeah, so let's do this now. So now let's bring it back up maybe, right? And also, well, let's do it in steps. So this will be negative y squared over secant of 1 over y, tangent of 1 over y, like that. So you could leave it like that, or you could simplify it even more, right? You could write secant as 1 over secant as cosine, and 1 over tangent as cotangent.
If you left it like that, would that be?
Yeah, that'd be fine. Yeah, this would be fine. So let's just leave it like that. So let's just leave it like that. Initially, this is not how I wanted to do it until Aaron suggested it, and I'm glad he did, because this is easier than my way. My way, I wanted to do a bunch of stuff. I wanted to bring this down and like multiply by y squared, you know, because you could do that, right? And then I wanted to divide by that at the same time, but that's like too much brain power. So I like his way. Just divide by all of this, boom, and then I put the negative up here. And then you can stop there or you can stop here. Either would be acceptable. Good. Good stuff. It's good math. It's good math. It's like calculus. Now it's like calculus, like some heavy derivatives, some heavier stuff. So, yeah. Good stuff. Any questions on this stuff? All right, let's go to the next section then.